Our story begins approximately 4.5 billion years ago in the swirling chaos of a nascent solar system. Dust and gas, remnants of a long-gone supernova, orbited the young sun. Gradually these particles began to coalesce, drawn together by gravity's relentless pull. Larger clumps formed, becoming planetesimals, the building blocks of planets. One such planetesimal, destined to become our Earth, continued to attract more matter. The energy from these countless collisions transformed into heat, melting the young planet's surface into a fiery ocean of magma. This early Earth was a hostile and volatile place bombarded by asteroids and comets. Volcanic eruptions spewed molten rock and gases into the atmosphere, creating a toxic and uninhabitable environment. Yet, within this cauldron of cosmic chaos, the seeds of life were slowly being sown. The very elements that make up our bodies, carbon, nitrogen, oxygen, were present in this primordial soup. As the bombardment of asteroids and comets subsided, the Earth began to cool. The molten surface solidified, forming the first crust. Volcanic activity reshaped the landscape, creating new landmasses and spewing gases. The early atmosphere was a mix of water vapor, carbon dioxide, and nitrogen. As Earth cooled, water vapor condensed, forming vast oceans. These oceans provided the environment for the first organic molecules to form. The stage was set for the emergence of primitive life forms. The early Earth was not alone in its journey. A dramatic event known as the Giant Impact Hypothesis occurred early in Earth's history, leading to the formation of our moon. Scientists believe that a Mars-sized object called Theia collided with the young Earth. The impact was catastrophic, sending debris hurtling into space. This debris, a mixture of material from both Earth and Theia, eventually coalesced under its own gravity, forming the moon. The impact also tilted Earth's axis, giving us the seasons we experience today. The moon's gravitational pull stabilizes Earth's rotation, preventing drastic wobbles that could have led to extreme climate fluctuations. The formation of the moon was a pivotal event in Earth's history. It not only gave us our celestial companion but also played a crucial role in shaping Earth's climate and environment, making it more suitable for the development of life. Beneath the early oceans, a dramatic transformation was taking place. The Earth's crust, still thin and fragmented, was constantly shifting and reshaping. Volcanic activity continued to release molten rock from the mantle, adding to the growing landmasses. Over millions of years, these landmasses grew larger, eventually forming the first continents. These early continents were not the stable landmasses we know today. They were constantly moving, colliding, and breaking apart, driven by the forces of plate tectonics. The movement of these plates created mountains, valleys, and deep ocean trenches, shaping the Earth's surface into the diverse landscape we see today. The formation of continents was a crucial step in the development of life. Continents provided stable platforms for the evolution of terrestrial ecosystems. They also influenced ocean currents and weather patterns, further shaping the environment. Section 5. The Spark of Life, Early Organisms. In the warm, shallow waters of the early oceans, the stage was set for the emergence of life. The exact details of how life arose remain a mystery, but scientists believe that organic molecules, the building blocks of life, formed spontaneously in the Earth's early environment. These molecules, including amino acids and nucleotides, combined to form more complex structures, eventually leading to the first self-replicating molecules. The first life forms were simple, single-celled organisms, likely similar to bacteria or archaea. These early organisms thrived in the harsh conditions of the early Earth, obtaining energy from chemicals dissolved in the oceans. They were the pioneers of life, paving the way for the incredible diversity of life that would follow. These early organisms, though simple, possessed the remarkable ability to replicate themselves, passing on their genetic information to the next generation. This process of replication, with occasional errors or mutations, is the engine of evolution, driving the diversification of life over billions of years. Section 6. The Great Oxidation Event, a breath of fresh air. Around 2.4 billion years ago, a dramatic transformation occurred in Earth's atmosphere. Photosynthetic organisms like cyanobacteria evolved to produce oxygen from sunlight. This oxygen began to accumulate, changing life on Earth forever. Known as the Great Oxidation Event, it was a turning point in Earth's history. Rising oxygen levels led to the extinction of many anaerobic organisms. but it paved the way for aerobic organisms which need oxygen to survive. Oxygen also led to the formation of the ozone layer, protecting life from UV radiation. This allowed life to colonize land, opening new habitats and opportunities. The Great Oxidation Event reshaped life on Earth, setting the stage for complex organisms. Section 7. Life explodes, the Cambrian explosion. Around 540 million years ago, life on Earth exploded in diversity. This period, known as the Cambrian explosion, saw the rapid appearance of a vast array of new life forms. Many of the major animal groups we see today, including arthropods, mollusks, and chordates, first appeared during this time. The Cambrian explosion was a period of rapid evolutionary innovation. New body plans, sensory organs, and predator-prey relationships emerged, driving the diversification of life. The oceans teemed with bizarre and wonderful creatures, a testament to the power of evolution. The causes of the Cambrian explosion are still debated, but several factors likely contributed. The increasing oxygen levels in the atmosphere may have played a role, providing the energy needed for the evolution of more complex organisms. Section 8. From sea to land. Life conquers new territories. For billions of years, life had been confined to the oceans. However, around 470 million years ago, plants began to colonize land, followed by animals shortly thereafter. This was a major step in the history of life, opening up vast new habitats and opportunities for diversification. The first land plants were simple, non-vascular plants, similar to mosses and liverworts. They gradually adapted to the challenges of life on land, developing structures to absorb water and nutrients from the soil and to prevent desiccation. Animals soon followed, evolving adaptations for breathing air and moving on land. The colonization of land was a transformative event, leading to the evolution of a vast array of terrestrial ecosystems. Life had conquered a new frontier, expanding its reach across the planet. Section 9. Mass extinctions and new beginnings. The history of life on Earth has been punctuated by periods of mass extinction, events that wiped out a significant portion of the planet's species. These extinctions, often caused by catastrophic events such as asteroid impacts or volcanic eruptions, have reshaped the course of evolution, paving the way for the rise of new life forms. The most famous mass extinction occurred 66 million years ago, when an asteroid impact wiped out the dinosaurs along with many other species. This event allowed mammals to diversify and eventually become the dominant land animals. Mass extinctions, though devastating, have played a crucial role in shaping the diversity of life on Earth. Each mass extinction has been followed by a period of recovery and diversification. New species evolved to fill the ecological niches left vacant by the extinct organisms. Section 10. The Age of Mammals, Rise of the Primates. Following the extinction of the dinosaurs, mammals diversified and radiated into a wide variety of forms. One group of mammals, the primates, evolved unique adaptations such as grasping hands and feet, binocular vision, and large brains. These adaptations would eventually pave the way for the evolution of our own species. Primates evolved in the trees, adapting to a life of climbing and foraging. Over millions of years, some primate lineages ventured down from the trees, adapting to life on the ground. One such lineage eventually led to the evolution of hominins, the group that includes humans and our extinct ancestors. The evolution of hominins was a long and complex process, marked by the development of bipedalism, tool use, and increasingly large brains. These adaptations allowed our ancestors to thrive in a variety of environments and eventually develop complex language and culture. Section 11. Humanity's Impact and Earth's Future. Humans have become a dominant force on Earth, shaping the planet in profound ways. Our activities have led to significant changes in the environment, including climate change, habitat loss, and pollution. These changes pose a threat to the planet's biodiversity and the future of our own species. However, we also have the capacity to be stewards of the Earth, protecting its ecosystems and ensuring a sustainable future. By understanding the history of our planet and the interconnectedness of life, we can make informed decisions that will benefit both humanity and the natural world. The future of Earth is in our hands. We have the knowledge and the technology to address the environmental challenges we face. By working together, we can create a future where both humanity and nature thrive. A future where the story of life on Earth continues to unfold in all its wonder and diversity.